Hi ladies and gents, Mary here, and we are going to talk about convection. There are three different ways heat can be transferred: conduction, convection, and radiation. And in this video, we're concentrating on convection. Now, the definition of convection: it's a transfer of heat within a fluid caused by differences of temperature and density within that fluid. Now, fluids include not just liquids, but they also include gases like the air that we breathe, and gases in sort of gas tanks used by scuba divers and things like that, and also plasmas. We're not talking about blood plasma here. We're talking that highest state of matter, things that are very, very hot and energetic. So we're talking about lightning, we're talking about the plasma that makes up the sun, all of these very highly mobile kinds of matter, gas, liquids, and plasmas, basically everything that's not a solid. Now, convection causes things that are called convection currents. So we're going to spend a few minutes. This is my stylized drawing of a pot on a stove, and it's going to contain some sort of a liquid, and I'm going to do something wacky. Instead of having the heat source distributed evenly throughout the bottom, I'm only going to heat it on one side. So think of a real powerful birthday candle on one side trying to boil a pot of water. So here's what's going to happen. The water directly above that heat source is going to get warm because it is due to conduction. It's touching this heat source. The metal pot is a good conductor, so it's going to get warm. Well, when things get warm, they expand. So the water here is going to get warm. It's going to expand. It is going to also become less dense because the same amount of water is now going to, these water molecules are going to vibrate further and further apart as they get more kinetic energy and hotter. So they're going to get warm, they're going to expand, become less dense, and they are going to rise. So the water here, right above the heat source, is going to move upward. Now, as they move upward, they're going to get further and further away from my heat source. Further away from the heat source, they're next to the cool outside air. And what happens here is the water up here is going to cool because of its contact, its conduction with this cool air. It is going to become more dense, and it is going to fall. So as this gets more dense, cooler, and falls, what it creates is a circular, round, curved pattern. And this is referred to as a convection current. Convection currents are these round patterns of hot air or hot fluids rising and cold fluids falling. And we see them in lots and lots of different applications. Now, of course, the most common example of convection is a rolling boil on the stove. When you boil a pot of water, if you get it to a point that you can see the water sort of bubbling and boiling, you are getting massive convection currents that are actually occurring due to that heat source. And the slightly colder water at the top is falling down to be reheated, and you get really a very good mixing from hot to bottom of temperature due to convection currents. Another place that you may see this in your home is if you have a convection oven. So what's the difference between a convection oven and a typical oven? Typical ovens do not have a fan in the back of the oven. A convection oven just has a fan. Usually they come on at a certain temperature. In my oven, it comes on at 375 degrees. And when it's hot enough, what it does is it blows heat over and across the food. What it allows a baker to do is a couple things. One, and this is used a lot in commercial bakeries, it allows you to have multiple pans of things baking at once. I don't know about you, but in the past when I have had company or friends over and I've got a couple pizzas, I'm not a gourmet cook, so maybe I'll have 2 pizzas in my oven at once before I had a convection oven. And about partway through it, I'd have to do the pizza flipperoo. I'd take the top one and put it on the bottom, and the bottom one and put it on the top, because they didn't heat evenly inside of my oven. Hot air has a tendency to rise, so the top of this one would get brown and the bottom of this one would get brown, and they'd both be kind of raw in the middle. With a convection oven, It is blowing that hot air evenly throughout the oven, and it allows you to cook on multiple trays, multiple layers at once. Moves that hot air around. Now you see convection in your home heating system. Most home heating systems are going to be located in the basement. And the reason you're going to put a furnace in the basement is the people installing the HVAC want to take advantage of natural convection currents. The hot air from your furnace is going to naturally come up through the ductwork into your home, and it is going to twirl around your airflow. The cold air returns back to your furnace, and there's basically a big monster convection current that is going to go all the way through your house. And that rising of hot air from your furnace is just due to the warmth and the buoyancy of that air. Now, yes, most furnaces are going to have some sort of a blower on them, but they're taking advantage of the natural convection of that hot air. This is supposed to be an attic. Now, I don't know about you, but when I go into the attic in the summertime, it is downright hot. Hot air has a tendency to rise, and that is due to convection. So if I go trying to clean the attic out in mid-August, holy moly, that is hot. And that again is due to that convection currents and hot air rising. This is an infrared photograph showing a very hot roof. It typically happens that your upper stories are going to be warmer and your lower stories are typically going to be cooler. A lot of basements have a tendency to be cooler. Attics have a tendency to be hotter in the summer due to natural convection. Those of you who've ever lived in the country and put hay in the hay mow in the summertime, it is a very hot job, and it's due to the fact that you are going above into the high areas of the barn. Very often down below you have animals that are emitting heat, body heat, and maybe you don't have animals down there emitting body heat, but hot air is going to rise. It's a hot, sticky job, but one of the reasons that putting up hay is so warm is that natural convection. That hot air is going to rise. Many people in the summertime go to the lake or they go to the ocean, and they do this because it's typically cooler there. And one of the reasons it's cooler at the lake or the ocean in the summertime is due to breezes near the shore. So let's talk about these breezes near the shore and how they work. So let's talk about what happens if you are, here's the lake shore, and on a nice sunny day. And this is supposed to be my lake over here. Water, as you know, has a very high specific heat. So as the sun beats down on a nice hot summer day, the water is going to heat up more slowly, and the land is going to heat up more quickly, and the land is going to get warm. Because the land is going to heat up more quickly, the air above it is going to get warm, and hot air is going to rise. The cooler lake or ocean water is not going to heat up as quickly due to its high specific heat. And so during the day next to a lake or the ocean, there tends to be, as the warm air rises, something has to go in and fill it, and that is the cool air from above the water, and you end up with breezes off the nice cool water towards the land. So you get those lovely breezes towards the shore that cool you off on a nice hot summer day. Now what happens at nighttime? Well, at nighttime, it takes a while for this to flip over, but the ground cools off much more quickly than water, again, due to water's high specific heat. So the ground is going to become cool, and the air above the water is going to stay warmer, again because of the fact that water has that high specific heat. It's not going to change quickly like the dirt of the ground is going to. So what happens is there's going to be water rising, hot air rising. I said water rising, sorry. Air rising above that warm water. Cooler land, because that land's going to cool off more quickly. And so in the nighttime, you're going to have breezes from the shore onto the lake, and people who sail boats, who actually have sailboats, they know about these breezes and they incorporate them in their training about how to sail. Of course, there's going to be changes between day and night when you don't have these offshore and toward shore breezes, but that's part of what you learn when you're going to be a sailor. Now, our weather systems have a lot of convection currents in them, and this is not a big course in weather, and so we're not going to spend all day about this, but I want you to understand that thunderstorms have huge, massive updrafts in them and then downdrafts in them. Well, this is due to differences in temperature, and that is basically updrafts and downdrafts are nothing but convection currents. We have a tendency to see our weather flat on weather maps that are shown to us on television, but I love this picture. It gives you an idea that there are big convection currents that are happening three-dimensionally in our atmosphere. If you want to become a meteorologist, really cool stuff. If you remember when you've taken earth science, most people, junior high or high school, they had a little earth science, and most people enjoy learning about plate tectonics and the fact that the earth's plates actually move. These are generated or actually move because of convection. Mid-Atlantic ridge in the middle of the Atlantic Ocean, there is hot magma that is rising from the inner hot core of the earth. This hot magma, as it rises, it cools, it sinks, and this is a huge monster Earth-sized convection currents that causes seafloor spreading, causes North America and Europe to be separating, and we're running over the Pacific plate, giving us volcanoes and earthquakes on that western coast of the United States. And it's driven by convection. Now, I live in the North Country, and our lakes every year actually completely turn over. So I want to go through a simple lake or simple pond and what happens with convection through the year in a little pond or lake. So in the summertime, as the sun beats down on a lake, it is going to get warmer. And as you may remember, if you've gone swimming in the summer in a lake or a pond, you know that the water has a tendency to be warm near the top. And if you go swimming in May, you're going to find that this is a very thin layer. Well, all summer, more and more heat from the sun heats our water, and the layer of warm water gets thicker and thicker and thicker. And this happens all summer long. Well, warm water is less dense than cool water, and so this is the way it stays. The warm water floats above the cool water, and that's what keeps our nice warm summer lakes. In the fall, the cold winds start to blow. And as the cold winds start to blow, it cools the water at the top. Now, it will cool this water at the top until it gets to a point where it is cooler than the water down below. As it cools the water on the top, it becomes more dense and it's going to sink. And the water on the top, as it becomes colder and more dense, it's going to sink. And this is going to keep going until you have a complete mixing of all the water in that pond or lake. Now, this occurs until everything in the entire pond or lake is 4 degrees Celsius. That is the temperature at which everything is going to be the most dense, and that's where water is going to be the most dense. But in the winter, the cold winds keep blowing, and it's going to make the water at the top go down to 3 degrees Celsius. Well, 3 degrees Celsius water is less dense than 4 degrees Celsius water. So that water is going to stay at the top. The winds keep blowing, and it goes from 3 degrees to 2 degrees to 1 degree to 0 degrees. And as the heat it continues to be removed, you start getting ice. Ice is less dense than the 4 degree water down below. As the winter progresses and more cold air blows across your pond, the lake gets thicker and thicker and thicker with ice. And this is pretty nifty because this allows fish and wildlife to stay alive in those low, deep regions inside of ponds. Now, I live in an area where a lot of people have small private ponds, and if someone has a pond that's not very deep, I've had a lot of neighbors that on a hard winter, their whole pond freezes out and their fish all die, which is very, very sad. But this is the process, and it's all due to convection. All right, that will do for convection. We'll come back next time and talk about radiation.